Hi, this is Juan Tutors, and today we are working on the August 2025 Algebra 1 Regents. This is the most recent Regents I was given, at least according to the date that I'm recording this. But we are going to go through this test. Now, I wanna just be clear about how I'm gonna go through this test. I've been doing a lot of videos in which I show process of elimination on many of the problems, but I started realizing that what ends up happening is that I start focusing so much on process of elimination that I don't get even an opportunity to talk about more of the rigorous stuff, the stuff that raises your grades to a 90 or 100 in a higher quality way. Um, so I realized that what I should do is I should make one video that really super duper focuses on process of elimination, um, and as many methods of process of elimination as I can, and then for this one I will also do the problem. So this video may be a little extra long, but then for future videos, what I'm going to do is I'm going to focus on how to do the problems and how the math works, and that way you get a taste of both the methods of test taking strategies and how to do the problems. Now, that said, am I going to just not do process of elimination or other methods of getting the right answer in other problems? Yeah, I'm definitely going to do that in other tests, but the difference is that I'm not going to be putting 100% focus on that, or even 50% focus on in terms of time. I am going to just very quickly say those things and then move on. In this case, we are going to be focusing a lot on this test on methods of process of elimination. One of the things that they say is to show all work. They do say that in the instructions. You may know that you do not have to show all your work. You don't have to display your work for the grader on the part ones. But one of the things that I've said in many of the videos that I've done is that the part ones are literally part twos in disguise. Basically, part ones and part twos are essentially identical. The difference is, of course, that part ones have a multiple choice and part twos don't. So just a minor rewording of a question, you know, and then giving choices or not can turn a multiple choice question into a short answer question and vice versa. And in fact, the part threes and fours are also multiple choice questions in disguise, just that those are multi-part questions and having to do with the same topic. So what does that mean for us? It means that if we want to do the best that we can on this test, we have to move away from the idea that we don't have to show work on the part ones, but we do have to show work on the part twos, threes, and fours. In fact, the way to maximize your grades is to show work on every single question, including part ones. And I will tell you this, that the majority of tests that I grade are blank for the part ones. The booklets are blank on the part ones because students don't show work. So we are going to do the best that we can with the time that we have. And we're going to use as many methods as possible, especially focusing on process of elimination. With that, let's jump right into number one. Which expression is equivalent to 100x squared minus 16? Is it 50x minus 8 times 50x plus 8? Or is it 50x minus 8 times 50x minus 8? Or is it 10x minus 4 times 10x plus 4? Or is it 10x minus 4 times 10x minus 4? Now, if you recognize the difference of two squares, you might be able to get the answer pretty quickly. This is a difference of two squares. But if you don't recognize that, so let me just write that down. A difference of two squares or difference of perfect squares, whichever acronym your teacher prefers, either one of those is perfectly valid. Those are great ways of recognizing what the answer should or shouldn't be. Square root of 16 is 4, so that it's going to have a 4 at somewhere involved, right? But we talked about other process of elimination methods. I'm going to pull out my calculator, make this a little smaller so you can see the screen, you can see the problem, and I think this has to get a little bit smaller. There we go. And I'm gonna graph. And by the way, this video is tall so that you could see more work. So it is a tall form video. So one of the ways that I could do the problem is I can go into the calculator and I could press y equals and I could type in the original 100x squared minus 16. And I could type in whichever answer I think is correct. Like suppose that I thought the answer 4 was correct. I would type that in. And you might think that it takes a long time to type this in. But the truth is, if, let's say, for example, number 4 is not correct, and you thought one of the other ones was more correct, you could literally just modify this choice on the calculator very quickly. So typing in the first one takes a while, but typing in the second, third, and fourth don't take longer. 10x minus 4. And I can go to the graphs, and that's one way to do it. And I see this parabola, and then I see this other parabola. I'm going to speed these up. And they are not identical graphs. Okay? They are not identical graphs, therefore they're not the same. But another way, a lot of students like to go to the table, and that's actually a really great way of comparing. And we see that the table of values on the y-axis are not the same. Therefore, these are not the same function. However, I do see that both of these parabolas are thin, so I'm going to cross this one out, but I suspect that maybe choice 3 is the right answer. And look how easy it is to type choice 3. 10x minus 4 times 10x plus 4. Just replace this minus with a plus, and I go to the graph, and I see a... why did that not graph? Oh, because I thought I pressed the plus. And by the way, any little minor errors, I'm going to catch it. Let me just talk about errors real quick. If I do make a mathematical error and I don't catch it, please let me know. The first student who catches a mathematical error that I make and mentions it can get a free hour of tutoring from me. Clearly, I have my logo here, JuanTutors.com. That is one of my main jobs. I am a full-time teacher, but I also tutor. And yeah, if you find that I make a mathematical mistake and I don't catch it, but you do, please let me know. Okay, and you'll get one free hour of tutoring. Okay, so now if I graph these, that's the blue one, and the red one right above it, right on top of it. And if we go to the table of values, the table of values are identical. Okay, so the answer to this one is number 1. Let me minimize the calculator though. But we wanna know how to do this one on paper, because part 2s, 3s, and 4s can easily be on paper. So we want to know that p squared minus q squared is equal to parentheses p plus q times p minus q. Okay, and where does that apply here? Well, this is a perfect square. This is 10x squared minus 16 is also a square, 4 squared. So we let p equals 10x and let q equal 4. And that gives us the factorization 10x plus 4 times 10x minus 4, which by the commutative property of multiplication is identical to choice 3. Number 2, Josie has $2.30 in dimes and quarters. She has 2 more dimes than quarters. Which equation below can be used to determine x, the number of quarters that she has? So if x is the number of quarters, they said it. Then the number of quarters should get multiplied by the value of a single quarter. And the ones that have that are this one, choice 3, and this one, choice 4. But choice 1 and 2 do not have that. Okay, so let's and I see why choice 1 was created. It was a false distributive property error. But that said, which one of those, choice 3 or choice 4, has the correct expression for the number of dimes. The number of dimes has to also get multiplied by the value of a single dime. And then that quantity is equal to the total value. $2.30. So all of them have equals $2.30. So, but if we notice the other piece of, so that does confirm that choice 3 and choice 4 makes sense. But the next piece of information that that the problem says that she has 2 more dimes than quarters. Then a lot of students mess this one up because they try to guess at what that represents. Then and they kind of put the plus or the minus in the wrong place. So 2 more dimes than quarters. So that means if she has more dimes than if she has 3 dimes, that means that she has 1/4. And vice versa, if she has 1/4, she has 3 dimes. If she has 4 dimes, then she has 2/4, right? 2 more. If she has 3/4, then she has 2 more than that, 5 dimes. Okay. So now I see a relationship that the number of dimes is, like they said, 2 more than the number of quarters. They said it in words, but now that I see numerically, if how do I get a 5 out of a 3? How do I get a 4 out of a 2? How do I get a 3 out of a 1? And this is equal to the number of quarters plus 2. This is equal to the number of quarters 2 plus 2. This 3 is equal to the number of quarters 1 plus 2. So if I take the number of quarters, if I have x quarters, that means that I have x plus 2 dimes, which is what choice 3 says, not what choice 4 says. So choice 3 is the answer. So that process of elimination method, or rather that method that we use to get the problem, is really the method that I would discuss on another test. That's the way to do this problem. It's really difficult to eliminate answers in any other way. That said, other things you could do, you could graph this one too, and go to the table, because you know that for some integer values of x, the dollar amount has to be exactly $2.30. So I can't guarantee that any one of these choices will have a non-integer answer, although I do suspect that choice 1 is going to have a non-integer answer. And the point is that any answer that does not have a non-integer answer has to be incorrect. Okay. Number 3, if g of x is equal to negative 2x squared plus 16x, then g of negative 3 equals negative 20, negative 2, 34, or 52. So what does g of negative 3 mean? You do have to know that g of negative 3 means g of x with x replaced by a 3. But if you don't know how to do that by a negative 3, if you don't know how to do that, this is yet another place where we can use the calculator. So I'm going to bring up the calculator. Okay. And there are things that you could do to predict also. Like for example, just to talk about another process of elimination method before I actually go on, in terms of size, negative 2x squared plus 16 is a positive number plus 16 plus a non-positive number, So it's a non-positive number. It could be 0 or negative, plus 16. So it's going to be less than 16, less than or equal to 16. And so that actually eliminates 34 and 52. So now that we have that process of elimination set up, let's actually then use the calculator to do the evaluation for us. Let's see. G of negative 3 equals, I'm going to shrink this calculator. treat the calculator just a little bit because it makes me have to zoom in a little bit, zoom out a little bit too much. There we go. Okay, so go to y equals again, and I'm gonna do, I'm gonna, I don't like clearing answers unless I run out of space, which I often do on a test, but I keep them just in case I want to go back. And here I'm gonna type negative 2 x squared plus 16. And then I'm going to go to the table. And I'm going to scroll up to x equals negative 3. And I see that at x equals negative 3, y is equal to negative 2. And so that is the answer to that question. And negative 3 squared is 9. 9 times negative 2 is negative 18. Negative 18 plus 16 is negative 2. And but with that, we'll go to number 4. What are the zeros of f of x equals x squared minus 8x minus 20? Are they 10 and negative 2? Or 10 and 2? Or negative 10 and 2? Or negative 10 and negative 2? Yeah, so great way to do this problem is, of course, to, blank plus blank equals b, which is negative 8, and blank times blank equals negative 20. And so you look at, let's say, negative 10 and 2. Negative 10 and 2, and those satisfy these conditions, and from there you do the factorization, which I'm going to write down at the end. But the way I'm actually going to do this one, again, it's a process of elimination video, so I am going to go back to my y equals, which now you're seeing that this is actually a very powerful tool, right? Press y equals, same as before. I take that off so I don't have to look at it, and I do x squared minus 8x plus minus 20, and I go to the table, and it'll tell me the zeros. Negative 2 is one of the zeros, so that eliminates answers that have a positive 2. And then the question is the other 0 negative 10, or is it the other 0 10? Let's go to 10. Oh, the other 0 is 10. There we go. So it looks like that's the answer. Now let's talk about how to use the numbers that we had found here to do the factorization. Negative 10 and 2 is, plus 2 is negative 8. Negative 10 times 2 is negative 20. And so what these numbers tell us is that we could factor this way. X minus 10 and x plus 2. And that's equal to 0. And then we could solve each of these factors individually, set each factor equal to 0. We get that x minus 10 equals 0, plus 10 plus 10. We get x equals 10. And we also get x plus 2 equals 0, minus 2 minus 2. We get x equals negative 2. Okay. Hopefully this video is going good for you so far, and hopefully you're getting these questions right. I do recommend making sure you choose an answer before you hear what I said. And don't say, oh, I think it's this. You're not allowed to say, I think it's that. You have to say, I'm going to guess this one. You have to commit to a single answer before you find out which one I choose. That's the best strategy right now. Another best strategy is to actually write down the way I do it. Especially if the test is like tomorrow or in a few hours, that muscle memory you'll get is really phenomenal. Number 5, which point lies on the graph of y equals 3x squared minus 1/4 x plus 3? Is it negative 2 15.5 or negative 1 5.75 or 1 6.25 or 2 15.5? Now, is there anything that I could do in terms of size that can get me this answer? I see that this is subtract. Well, 3x squared is going to be a non-negative number, and it would only be 0 at 0. So for all of these choices, 3x squared is going to be positive. This number that we're subtracting is a pretty small number, so I suspect that 3x squared is going to be big relative to the minus 1/4 x. Okay. And then plus 3, so the answer is going to be greater than 3. But then I have to make approximations on what what the answer might be if I plug in a 1 or a 2 or a -1 or a -2. If I plug in a -1, I get a 3 here. 3 plus 3 is 6. I get something that's slightly less than 6 for x equals 1, and I got something slightly more than 6 for x equals -1, which is the opposite of what these two say. And so the answer has to be one of these others two. And I see that the answers actually match 15.5 and 15.5. So the question is really which one gets reduced. Um, Again, this one's less than 6. This one's greater than 6. That's how I eliminated those. Which one gets reduced for when you plug in a positive number? If I plug in an x equals 2 or a -2, I get 18. I'll get a 12 plus 3 is a 15. And then if I plug in a positive number, this gets reduced. So this is a less than 15. And if I get a plug in a negative number for x, this gets increased by that middle term. And this is greater than 15. And so the answer that matches that is choice 1. So let's actually, how do I do this problem? Again, calculator is a huge benefit. I am going to plug this one in on the, yeah, I'm going to plug it in on the calculator. Now I've plugged it in the y equals way. That's actually a way that I personally recommend more than any other way because it's easier to see that we plugged in the expression correctly, where as opposed to plugging in the numbers. Plugging in the numbers, students have been resisting writing parentheses when their teachers have been telling them that they're required since the 4th grade, right? Or 2nd grade, whenever your teacher happened to teach you parentheses. And now we're in Algebra 1 class and we're like, we don't know when to put parentheses because we just feel like we're not supposed to, or because we feel like we don't have to, so we don't. When in fact, teachers have not been telling you to put parentheses because they want you to put them, but because they're actually required. So for completeness, I'm going to plug this one in here to show you that when I plug in a -2, I do have to use parentheses. I have a y equals, when x equals -2, y equals 3 times parentheses -2 squared, okay, minus a quarter. Okay, test taking strategy. The test does allow you to put in fractions. So let me go again. I pressed the math button. I went one to the right to number. Went to the last one, n over d. I'm going to put an actual fraction 1/4. A lot of teachers don't know that you could do that. Now you do. 1/4 times parentheses -2. Then that plus 3. And I get 31 over 2, which unfortunately is not an integer. So I'm going to convert this back to a decimal. Or arrow frac. Nope, not arrow frac, arrow decimal. So I press the math button. The very first option converts a rational number into a fraction, and the second one converts any number into a decimal. 15.5, which is exactly what our prediction method said. Minimize this. Number 6, given f of x equals x squared and g of x equals 8x minus 15, graphed on the same set of axes, which values of x will make f of x equal g of x? Is it 3 only, or 9 only, or 3 and 5, or 9 and 25? We could do this by graphing, and we could do this by table. And let's look at the calculator again. Notice that number 1 through number 6 could all be done by pressing y equals. So is pressing y equals and using the graphing utility useful? I would say yes. But another way to do this problem, because again, I press y equals and I look at the tables and I compare the graphs. So it's important to know that that's one method. What about another method? Another method is plugging in test values. If I plug in a 3, f of 3 equals 3 squared, which is equal to 9, and g of 3 is equal to 8 times 3 minus 15, which is 24. This is not an arithmetic test. This is an algebra test. So plug 8 times 3 minus 15 into the calculator. Let that do it for you. But that is equal to 9. Okay? So 3 actually is a valid answer. 3 is a valid answer. eliminating 9 only, and also eliminating, now technically speaking, does that eliminate 9 and 25? Maybe they missed a 0, but they don't on the Algebra 1 test. They don't do that. That's one, but that's more philosophically true as opposed to mathematically true. Uh, so can we technically eliminate choice 4? Not technically, because maybe there's another 0. But there is something that allows us to eliminate choice 4. This is a quadratic equation, a quadratic function, and a linear function. They parabolas and lines intersect at most 2 numbers, at most 2 points. So if the answers to this question are 9 and 25, that means it would be only 9 and 25 because those are 2 separate x values. So that does eliminate choice 4 because it is missing 3. So now the question is, what about x equals 5? So we could plug in x equals 5, and we get that g of 5 is equal to 8 times 5 minus 15, which is equal to 40 minus 15, which is equal to 25. And f of 5 is equal to 5 squared, which is equal to 25. They're both equal to 25, so the answer is choice 3. Now, if you are dedicated to doing the problem the way that you would on a part 2 question, because remember, this could easily be a part 2 question. In fact, this one doesn't even have to be reworded to make it a part 2 question. They just delete the multiple choices and that's perfect. How do you do it on the part 2s? You actually just set them equal to each other. You say x squared equals 8x minus 15. Subtract 8x. Also add 15. And you get that x squared minus 8x plus 15 equals 0. And blank plus blank. So again, blank plus blank equals negative 8. Blank plus blank equals negative 8. Negative 8 and blank times blank equals 15. And so negative 3 and negative 5 satisfy that. And so now I see that there's going to be 2 answers already, and it's going to be a 3 and a 5. But to complete the question, I factor x minus 3 times x minus 5 equals 0. And I solve these 2 equations. X minus 3 equals 0, and x minus 5 equals 0. I solve both of them, plus 5 plus 5. I get x equals 5. I'm sorry. Wow. I went a little bit early, looking at the right side. Plus 5, plus 3, plus 3. And I get that x equals 3. And I got plus 5, plus 5. And I get that x equals 5. So I got those 2 answers that I expected. Number 7, which trinomial is written in standard form and has a constant term of 5? Standard form and has a constant term of 5, so this is expanded. Trinomial. So do you have to know what a trinomial is? Yeah, absolutely. This one doesn't. This is one of the few problems that really is a definitional problem. So its process of elimination is eliminating the things that you know are incorrect. So individually, it says trinomial, standard form, constant term 5. So any of these that are not a trinomial, standard form, constant term 5, it can be eliminated. I know what the constant term is. I like, even as a student, so I think about fake student me. Suppose that one thing I knew is constant term 5 means that it's going to end up with a plus 5. It's going to end with a plus 5. That's a plus 10. That's a plus 1. That's a plus 5. That's a plus 5. So we've eliminated choice 1 and choice 3. That's the process of elimination method that works on this one. This is a definitional question, though. The only way to go about it and do it 100% correctly is by using all of the information that they give us. Now, expanded trinomial has 3 terms. Trinomial, implies 3 terms. Okay. But choice 1, 2, 3, and 4 actually all have 3 terms. So that doesn't eliminate anything. And then constant term of 5, we've eliminated 2 choices from that. And also standard form means that we put the polynomial in decreasing exponent order. And so this choice 2 has an x to the 4th term in the middle and an x to the 2nd term as the first term. We both know that a 2 is less than a 4 and a 4 is greater than a 2. So the 6x to the 4th to be in standard form would have to go to the front. So choice 2 is not in standard form. Choice 4, though, decreasing exponent order, a 5, a 2, and a 5x to the 0, so a 0 exponent. This is in standard form, decreasing exponent order. Number 8, when solving x squared plus 6x equals negative 8 for x, a student wrote x squared plus 6x plus 8 equals 0 as their first step. Which property justifies this step? Is it the associative property, the commutative property, a 0 property of addition, or the addition property of equality? Okay, so one way to do this problem is, again, process of elimination, where if we can identify what those words mean, then and they mean the wrong thing, we could eliminate it. A second part, though, is in the positive sense. If we can identify what operation was done and which one corresponds to that, great. So we do have to know, though, how they got from this very first equation to the x squared plus 6x plus 8 equals 0. Well, if I have x squared minus 6x, x squared plus 6x equals negative 8, the way I get an equals 0 on the right side is by adding 8. Adding 8. So what this student did was they added 8 to both sides of the equal sign. Which one allows them to do that? Is it the associative property, commutative property, or the 0 property of addition, or the addition property of equality? Yeah, so let's talk about these one at a time before the final answer. The 0 property of addition means that, like an expression n for any expression plus 0 is equal to the same old expression n. That's the addition property of equality. The commutative property of addition is that a plus b equals b plus a. You could change the order of addition. You could also change the order of multiplication. A times b equals b times a. You could change the order of multiplication. You can't do that with most operations. Most operations don't allow you to just change the order of the operations. The associative property says that if you have only addition, you could do that addition in any order. So a plus b plus c, doing the a plus b first is the same thing as a plus parentheses b plus c, doing the b plus c first. Or I'm going to write the multiplication one. Let me write it in a slightly different color so that we can see it better. A times b times c. So you can multiply that. If you're only multiplying a, b, and c, you can multiply the a and the b first, or you can multiply the b and the c first. But none of those two are actually happening here. None of those three are actually happening here. But what is happening on both sides is we are adding 8 to both sides. Both. Let me erase that a little bit. To both sides of an equal sign. That is the addition property of equality that allows you to do that. You can add, in fact, there's an arithmetic property of equality. If you have the same number on both sides of the equal sign, you could actually do any arithmetic operation to both sides of the equal sign, and that's legal. So you could do the same operation with the same number to both sides of the equal sign. And that's the arithmetic property of equality. So you could add the same number to both sides of the equal sign, and you get the same. You could still get a true statement. You could subtract 5 if you wanted to, although I don't even know why you would in this problem. But you could add 9 to both sides of the equal sign, and that is something that you might do when completing the square. And that's legal. You can multiply both sides of the equal sign by the same number, divide both sides of the equal sign by the same number. All of those are legal. And as long as you get something legal out of it, like not dividing by 0, for example, or taking the square root of a negative number, you do get the same number, which is allowed in Algebra 2 class, but not in Algebra 1 class. Then you get the same number. Number 9, the table below shows the input and output values for 4 different functions. Let's see, -2, -1, 0, 1, 2, 3, and then 6, 1, -2, -3, -2, 1. Let's see. Let me read the question before I go to the table, because I just see it's a table of functions, 4 tables of functions. So the question, we just read through them and see what they say. The question is, which table represents a linear function? Is it f of x, g of x, h of x, or k of x? Or j of x, rather. So linear functions increase or decrease at a constant rate, including a rate of 0, by the way. So a horizontal function, a horizontal line is a linear function. It's increasing at a rate of 0. So increase or decrease at a constant rate. And actually, I should add the word either. Either increase or decrease at a constant rate. Not both, not neither, both. So I see choice 1 is not decreasing at a constant rate. In fact, it's decreasing and then it's increasing. So this is decreasing and then it's increasing, right? So that's not the answer. So F is not the right answer. Do any of these others have that same property? Yeah, choice G, decrease, right? And then it's increasing. So choice G is not the right answer. And so then what about -1, -2, -4, -8, -6, -32? I do see a pattern there. If I multiply by 2, that is not increasing at a constant rate. It's increasing by a constant multiple. So that's not the answer. So when we say increasing or decreasing at a constant rate, which we mean that the same number for an increase of x, or the input, by 1, the output increases or decreases by a fixed number, by adding a fixed number, or subtracting a fixed number, whatever, because it could be adding a -4, which is equivalent to subtracting 4. But this one, I see choice 3, 4 gets added to it, 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 and 4 gets added to it as x increases by 1, right? So x increases by 1, y increases by 4, j of x increases by 4, so j of x is the linear function. Notice that the way I eliminated answers was actually I eliminated things that didn't quite make sense. We knew that a linear function, so even if you didn't know how to do this problem, we know that a linear function has to increase at a constant rate, at least increase or decrease, one or the other. So we could actually eliminate 2 of the choices, making a passing problem just by eliminating some choice, by eliminating the choices that don't just consistently decrease or consistently increase. Number 10, what is the solution set to the equation 3x squared equals 24x? Is it 8, or 0 and 8, or 0 and -8, or 0, 8, and -8? I do see, by process of elimination, this is a quadratic equation, which means that it has a maximum of 2 solutions. By the way, Algebra 2 kids would actually say that it has exactly 2 solutions, including repetition. Many Algebra 1 kids also say that. So it could have the same number repeating twice. However, I see that choice 4 has 3 solutions. And it's not, that's just greater than 2 solutions. So choice 4 is not the answer. So it's either 8 or 0 and 8 or 0 and -8. And just by process of elimination, I can plug in a 0. 3 times 0 squared is equal to 24 times 0. Sure it is. 3 times 0 squared is 0. And 24 times 0 is 0. Sure. So 0 is a solution. Which does also eliminate choice 1 because they said the solution set, which means all solutions. So now the question is, what other solution exists? And we could do 3x squared minus 24x what equals, oh sorry, equals 24x. Okay. And we could do minus 24x minus 24x. And we got that 3x squared minus 24x equals 0. And now we could factor out a common factor. I see an x as a common factor. I actually see also a 3 as a common factor. And I got factor pair x minus 8 equals 0. Let me move that over here a little bit. It's going to remove the answers, but we need some space. So 3x times x minus 8 equals 0. So by the 0 product property, either if the product equals 0, then one of the factors equals 0. So either 3x equals 0 divided by 3 divided by 3. So you got x equals 0, which is one of the answers that we said we got, right? Or x minus 8 equals 0 plus 8 plus 8, and we get that x equals 8. So great process of elimination method. Another process of elimination method, by the way, we've been pressing y equals on a lot of problems. Pressing y equals and then plugging in x equals 0 and x equals 8 would confirm that, in fact, choice 2 is the correct answer. Another one that you could do by size consideration, because I love size consideration as a process of elimination method. I've tutored a lot of SAT kids, and they found, and ACT kids, and they found that plugging in and using size considerations is a really useful way of doing the problem. For example, 3x squared is going to be guaranteed to be non-negative, greater than or equal to 0, whereas 24x can be negative. If you plug in a negative number into x, 24x is negative. And so choice 3 would imply that a positive number for x equals -8, a positive number equals a negative number, and that's just false. Love process of elimination. Love all of these extra methods. If you do appreciate all the methods that I'm showing you, please do hit the thumbs up. I mentioned that I tutor, and I will mention it here. JuanTutors.com. If you have any tutoring needs, or if your parents feel that you have a tutoring need, please do ask them to consider me. Number 11. The table below shows the radioactivity level of a substance after the given time t in seconds. The time in seconds goes from 0, 1, 2, 3, 4, and the radioactivity level goes 20, 10, 5, 2.5, 1.25. So, what is the average rate of change in the radioactivity level over the interval 1 to 3? So, the average rate of change is how much the time changes. 3 minus 1 equals 2. And how much the radioactivity changes. Notice that this is decreasing, which means that the average rate of change is negative. It's less than 0, which does eliminate choice 3 and choice 1. Boom, process of elimination eliminated a whole lot of answers, didn't it? And from 1 to 3, though, how much does it decrease by? Final minus initial is 2.5 minus 10, which is equal to 7.5. And at that point, negative 7.5. And at that point, I would plug in into the calculator. Negative 7.5 divided by 2. Again, we said that we do process of elimination. That blocks the 7.5 because my calculator is giant. But let's quit here. Negative 7.5 divided by 2 is negative 3.75. Of course, as a mathematician and as a math teacher, I did know the answer, but we are talking about test taking strategies, and I wanted to model for you the fact that this is not an arithmetic test. This is an algebra test. In fact, if there's any point that you arrive at where they're asking you for the for arithmetic to be done, you don't have to do a single bit of it. You could literally just immediately write down the final answer from the arithmetic. You do have to show the algebra on paper. That's the rule. You have to show the algebra on paper. You can do the arithmetic on the calculator. So then what's the difference between the arithmetic and the algebra? Arithmetic is when you're working with numbers, pure numbers and operations. And whereas algebra, you're working with variables and numbers and operations. Okay? The big difference between arithmetic and algebra is actually, in fact, the arithmetic is the study of numbers, and algebra is the study of operations. So if you've ever wondered what the difference between those two is, so why do we have to show all our steps when there's x's involved or y's involved or x's and y's involved or q's and p's or letters involved? Because that is algebra. You're working with operations. When there's variables, you can't combine like a q and a 7. So you have to focus on the operations. But if you have a 15 and a 7, you can just add those on the calculator. In fact, if you have a 15 and a 7 multiplied by 2, all of that divided by 4, you're allowed to do that on the calculator. Number 12, Fred recorded the number of minutes he read each day from Monday through Friday. His results are shown in the table. And I see, I do read the table usually pretty quickly. 1, 2, 3, day 1, 2, 3, 4, 5, and the number of minutes read 12, 16, 19, 27, 29. I just let that sit in my head, but I don't try to memorize what just happened there. I do see some trends. I see that the right side is increasing, right, as the days increase. But beyond that, I really don't do any processing. Well, what is the correlation coefficient to the nearest thousandth and the strength of the linear model of the data? Process of elimination, you do need to know that if the correlation coefficient is greater than 0.7, that this implies a strong correlation. So that actually eliminates choice 3 and 4. Process of elimination done. That's gone. So the question is it 0.984 or is it 0.968? And the truth is, I wish that I had a way to eliminate one of those two answers. I sincerely do not. And any teachers out there, if you have a way of eliminating answers, in this case between 0.984 and 0.968, please do let me know. I don't think there is a good one. I have a suspicion. And I am willing to be incorrect. So I do have a suspicion that it's choice 1, because I feel like this does follow a nice, very closer to linear function, with 1 point kind of slightly above and 1 point slightly below, and then the rest very, very close to the line. I do suspect that it's choice 1, but I honestly have to go to the calculator for this to be sure. I think it's choice 1, but I don't know. I go to the how do I do this? I go to stat, press the stat button, press the edit button, and then I put the 1, 2, 3, 4, 5, 1 enter, 2, 3, 4, 5. Test taking strategy. This is an actual test taking strategy from having to fix a lot of cognitive issues with so many students. This is a tutoring best practice test taking strategy. Plug in the numbers first and then check that you typed them correctly. But you can't skip either of those steps. Some students focus on checking that they typed every single number correctly every single time they typed a number, and it literally makes them get the question wrong. Other students are like, I don't have to bother checking, and they don't check the answer, and any mistyped answer, you're not going to be able to detect it because the calculator is going to give you an answer. So I checked that I typed in 1, 2, 3, 4, 5 correctly. Great. And then I plug in the minutes read 12, 16, 19, 27, and 29. And now I check my answers 12, 16, 19, 27, 29. Okay, good. Now I go to my screen where I do my calculations, and I do stat. Actually, there's one thing I have to do. Catalog. I have to go to the catalog. And I have to go all the way down to diagnostics on. So keep scrolling, diagnostics on, and I have to press enter and enter. Okay, there is another way to do it on many calculators today. There, you can go to the mode and look for a stat diagnostic. Let's see, stat diagnostic, stat diagnostic on. So that's another way to do it if your calculator has that option. Fun fact, the makers of this calculator often update the software. If they feel that it's a minor update, they don't update the serial number on the calculator. So not every calculator that is a TI-84 plus C Silver Edition will be identical in software. So I have to teach both of those methods. But stat diagnostics is on. Now I go to stat calc, and I go to linreg ax plus b. I wish they said mx plus b, but they don't. Ax plus b. A is the slope, b is the y-intercept. And then it's going to give me the correlation coefficient. 1 and 2, list 1, list 2, frequency list. Store the regression equation. If you wanted to store the regression equation, I do like doing that sometimes. I press the vars button, go to y variables, go to function, and I'm going to do like y5. I think I haven't used that one yet, but I'm not sure. y5, stored out with y5, and all right, so I got y equals 4.5x plus 7.1 with a correlation coefficient of 0.9838. I'm going to write this down. R equals 0.983856303. Now I can minimize the calculator, and then I can round to the digits that they did to the nearest thousandth. So R is approximately 0.98. Then the 3, because the 8 is greater than is 5 or greater, the 3 gets rounded up to a 4, 0.984, and strong. And actually, I was right. Nice. I was right about 1 being the answer. Number 13, given f of x equals x squared, which function will shift f of x to the left 3 units? Is it g of x equals x squared plus 3, or h of x equals x squared minus 3, or j of x equals x minus 3 squared, or k of x equals x plus 3 squared. So this one's an interesting one because it allows us to discuss something that is really a very useful piece of knowledge and is helpful for process of elimination. So the piece of knowledge is also helpful for process of elimination. We know that if we add a number to a function, that moves the graph of the function up 3. So up 3, and relative to y f of x equals x squared, and this one subtracts 3 from x squared, so this one moves the graph of y equals x squared down 3 in the negative direction. And so both of these are wrong because this does say left 3. But what about what can we say though about these other choices? X minus 3 and x plus 3. So here's the bit of intuition that I think breaks a lot of intuition in the beginning, and also breaks a lot of teachers' intuitions. So I'm going to make the statement, and then I'm going to let you think about the question why on your own. But the statement is this: if you add a positive number to a function, that moves the graph up 3. That amount. If you subtract the number from a function, that moves the graph down that amount in the direction of the sign of the operation. So if you perform the same operations on x instead of performing the operations on f of x, you perform the operations on x. Well, that has the opposite direction transformation as it would in the up and down direction. So if you add 3 to f of x, that moves the graph up 3. So if you add 3 to x, that doesn't move it in the positive direction, adding 3. It actually moves it in the negative direction, to the left 3. And then if you subtract 3 from x, that does not move the graph in the negative direction. That moves it in the opposite direction of what would happen in the y direction. So it moves it in the positive direction, to the right 3. So this is actually to the right 3. And this is to the left 3. And we could actually confirm on the calculator. Press y equals. I'll turn it on, then press y equals. Let me go to these functions. Okay. Equations 6, 7, and 8. And you're going to see choice y. The second one is y4, is choice 4, and the third one is choice 3. So first, the first graph, this is y equals x squared. Then this is y equals x plus 3 squared to the left 3. See that? And then this is y equals x minus 3 squared to the right 3. So in fact, choice 4, as I suspected, is the correct answer. Number 14, a class of 20 students was surveyed to determine the number of pets each student owned. The data represented in the data are represented in the dot plot below. And I see a dot at 0, 4 dots at 1, 6 dots at 2, 4 dots at 3, 3 dots at 4, 4 dots at 2 dots at 5. I just see a big jump at 2. That's the number of pets. I read that, but I don't fully internalize it because it's too much information to keep in mind while I'm reading. So that's it. I just look at the data and then I let it do what it does in my brain. The question is, which statement about the data is correct? Is it that the mean and the median are the same, or the mean, median, and mode are the same, or the mean and the mode are the same, or the mean, median, and mode are all the same? So here's an interesting thing. Suppose that the mean and the median and the mode were all the same. Suppose that these are all the same. But this is a multiple choice question and only one answer could be correct. That would imply that choice 3 is correct, because it doesn't say the mean and the mode only. It would also, it just says mean and the mode. This would imply that the median and the mode would be correct. This because the mean and the mode are correct according to choice 4. Are true, are the same according to choice 4. And then the median and the mean are the same. That would also be correct because according to choice 4, that would imply that the choice 4 implies that the median and the mode are the same. So if choice 4 is correct, then they're all correct as multiple choice questions. Therefore, because this problem can't have more than one answer, choice 4 has to be incorrect. Which means that I only have to check for the mean, median, and mode. And the moment I get 2 of them, I am done with the problem. So the mode is equal to the most often piece of data point, which is choice, which is 2. That's equal to 2. So now I'm going to check the median because that's the easiest one for me to calculate. If I cross out, let's say the first 5 points, 3, 4, 5, and I cross out the last 5 points, 2, 3, 4, 5. Then I cross out one at a time, 1 and 1, 1 and 1, 1 and 1, 1 and 1. Now the 2 remaining points are right here. So the median is the number between a 2 and a 2, which is equal to 2. So the mode and the median are the same, but it's the mode and the median. In fact, we confirmed that the mean is equal to 2.35, which is not equal to 2. So the mean is not the same, and we could cross out the ones that say the mean. This one is correct. On that note, number 15 will secure us a passing grade. So I'm really excited about that. And let's go on to that. Number 15. The range of f of x equals x plus 2 squared minus, I'm sorry. The range, let me restart that. Number 15. The range of f of x equals absolute x plus 2 minus 5 is y greater than or equal to negative 5, or y greater than or equal to 2, or x greater than or equal to negative 5, or x greater than or equal to 2. One way to do this problem is first, you do need to know what the range is, and the range is the set of y values in the graph. If you don't like this definition, math teachers, remember I'm doing test taking strategies here. This is actually a phenomenal definition for test taking strategies. If you were to graph this function, then the y coordinates would be that match point on the graph would be the would be the set of range values. So that means that choice 3 and choice 4 are eliminated because those are referring to x values. And in fact, that makes this a passing problem. I haven't talked much about passing problems, which I do talk a lot about them in other tests, but but probably less so when I'm reducing the amount of test taking strategies for other problems. But if you other tests, but if you notice, you need 29 points to pass this test, which is actually technically 14 and a half multiple choice questions, but you can't get 14 and a half multiple choice questions. However, 15 questions doesn't. 15 is definitely not half of 24 questions, 24 multiple choice questions. So why do I call this a passing problem? Because you really do need approximately half the multiple choice. Half the multiple choice is 12, but that's not 15. Why am I being a little so iffy about it? Well, because if you notice, 12 questions in multiple choice give you 24 points. You need 29 points to pass the test. That's 5 more points. If you can do test taking strategies to eke out 5 more points in the part 2s, 3s, and 4s, which is so doable, then you could definitely pass the test. Think about it. It's 5 points out of number 25 through 35. 5 points out of 11 problems. A little partial credit here and there. A little bit, oh, I just realized I actually know how to solve the problem. Or a little bit of, I know what the answer is because the calculator told me, and then I work backwards a little bit and just fill in the answer. They don't know that you wrote backwards. You know, many strategies there are to get points here and there on the test, on the part 2s, 3s, and 4s. One big one I'm going to show later when I get to the part 2s. That said, so if you get a few extra points here and there, you can get 12 multiple choice or even fewer and pass the test. So how do I do this one on paper? One way to do it, again, on calculator, we talked about how strong pressing y equals and graphing is, or using the table of values. And that's such an important way, including this one. Number 1 through 6 were able to be done that way. Many other ones were able to be done that way, but I didn't do them that way. Some of them I did do them that way. Using y equals actually can get you so close to a passing grade that it might actually more than half the time get you to a passing grade if you just press y equals and plug things in carefully and correctly. But one of the ways, for example, that students struggle on this question on the calculator, so I am going to do this because of test taking strategy. I'm not going to graph it this time, but I am going to show you how to put in an absolute value. Press the math button, go to the right to number, and the very first option in number is absolute. And so absolute, I'm going to take a test value, an easy test value, 0 plus 2, that minus 5, and I get a -3. So I know that -3 is in the range, and choice 1 says at y greater than or equal to 2. -3 is not greater than or equal to 2. -3 is not greater than or equal to 2, so that eliminates that answer. That leaves me with the only correct answer. How do I do that on paper? I recognize that x plus 2 absolute value is greater than or equal to 0, and this is just equal to -5. And so this whole thing is greater than or equal to 0 minus 5, which is, that means it's y is greater than or equal to 0 minus 5 is -5. Number 16, which equation is always correct? Is it that a to the third times a to the x equals a to the 3x, or a to the fourth that to the x, so a to the fourth in parentheses that to the x is equal to a to the 4 plus x, or ab in parentheses to the x is equal to a to the x times b to the x, or is it that a to the x times b to the y is equal to ab to the power of x plus y? And this is one that I'm going to highly recommend using your calculator and use the rare values. So you might say, what do I mean by rare values? So I take test values. I take test values and I separate them into 2 categories. So the 2 categories are numbers that are easy to plug in. So easy to plug in includes, like, for example, 0 or 1, sometimes -1 with a question mark. Roots are numbers that are easy to plug in, and then other special values. Okay, I can't just give a quick definition of other special values other than to say that I just mean that some problems have a particular number that happens to be very easy to plug in. Like maybe there's like if you plug in a zero exponent, then you could plug in any number in the base, for example, or something like that. Maybe some special thing about it makes another number easy to plug in. An absolute value, for example, number 15, great example. Absolute x plus 2. If I plug in a negative 2, I don't have to do any calculation. The inside is a 0, absolute 0 minus 5, which actually would give us the right answer. So it's not a bad number to plug in. But the next class of numbers is, and there's only two classes of numbers. It's not difficult numbers per se, because you have a calculator, but rare. Rare includes like 9 or 8 or 11 or 1.1, often pi for non-geometry problems, non-trigonometry problems. E is a number on the calculator that comes up in a lot of exponential problems. And it is on your calculator, by the way. A lot of students don't know that. E appears twice on your calculator. E to the power of 1 right there. E is above this ln button. And then the E also appears above the division button in blue. So if you press the blue second button and that E, it's a number that comes up a lot in math, believe it or not. There comes a point where it comes up more often than pi does. And pi comes up all the time. Okay, so the benefit of rare numbers is, why I call them rare, is that it's very, unlike the easy numbers. If you plug in an easy number, this is where, let's define it. If you plug in an easy number, it gives you an answer very quickly. But the test makers do a little bit of adjusting for those easy examples. And the math, just the existence of math itself, does a little adjusting by itself, because it happens to be that the easy numbers tend to give very easy numbers out, which makes the answers. So if you plugged in the easy numbers, it makes many of the answers not be eliminated very easily. So sometimes in other words, sometimes you get repetition. For example, if you let x be 1, y be 1, a be 1, b be 1, if you let everything be 1, you're just going to get 1 all over the place, and that's not going to eliminate any answers. However, if you do this example, and you let's let a be 9, let's let b be 8, let's let x be 7, and let y be 6, it's extremely unlikely that the test makers adjusted for this very rare choice of numbers. So if I plug in these numbers, it's very likely that I'm gonna confirm the correct answer. And I'm gonna plug in those numbers. I'm blocking off choice 3 and 4, but I'm gonna plug into choice 1, okay? So I'm gonna plug in A was 9 to the power of 3 times 9 to the power of x, which is, I said 7. And I get that answer. Now I'm gonna plug in the same numbers into the second side. I get 9 to the power of 3x, which is 3 times x is 7. If I get the same number, that's probably the correct answer. But I don't get the same number at all. I get something to the 20th power, 10 to the 20th power. Okay, so that eliminates this answer. And the fact is that if I did this for all 4 choices, if I did that for all 4 choices, I would get the answer to this question. But I do want to also, for those of you who want to know the rules of arithmetic that allow us to do this problem, you want to know the following 3 main rules. So a to the x, times b to the x is equal to, you can combine the bases in multiplication, a times b, that to the x. So that's rule 1. Rule 2 is that a to the x times a to the y. So now you have the same base but different exponents. That's equal to the same base a, but now the exponents get added, x plus y. The third rule is that a to the x and that to the y is equal to a to the x times y. I noticed that choice 4 seems to mix rules and or does 2 rules simultaneously, like combine the bases and combine the exponents. And unfortunately, it's actually, fortunately, I shouldn't say unfortunately. Fortunately, it's impossible to to perform two operations simultaneously. It's actually not possible. So we can eliminate choice 4 from basic principles, uh, or rather, we should be able to put an X next to it because we suspect that it's wrong. Let me pull out a different color here. We suspect that it's wrong, but I do see that choice 3 does match one of the rules. Where's the rule? It matches rule 1. Actually, no, it does not match rule 1. Yes. Yes, it does match rule 1. So that's the answer. Number 17, the formula for the area of a trapezoid is A equals 1/2 h times b1 plus b2. That is true. The height h of the trapezoid may be expressed as, what, 2a over b1 plus b2, or 1/2 a times b1 plus b2, or b1 plus b2 over 2a, or 1/2 a minus b1 plus b2. And I do want to eliminate choice 4 immediately because I need to think about what I need to do to solve for h. H is being multiplied or divided by numbers. I need to multiply or divide or multiply to eliminate those operations. So A is going to be multiplied and divided by numbers and not subtracted from by numbers. So choice 4 is incorrect. There are other things that I could do. Like, for example, I see that A and H are on the same numerator level. So the answer is, when we solve for H, has to have A in the numerator. A is in the numerator here, A is in the numerator here, A is in the denominator here. And so that's not the answer. And now I have a passing problem. I've eliminated 2 choices. Passing problem. I've eliminated 2 choices. So can I do this one? First off, algebraically, divide by b1 plus b2, and also multiply by 2 on both sides. Divide by b1 plus b2, and multiply by 2. And that should tell you the answer. However, what if I want to, I'm going to erase that work because this is the test-taking strategies video. What if I want to know how to do a test-taking strategy method? I'm going to choose slightly rare numbers, but easy to plug in. I'm going to let h be 2. I'm going to let b1 be 4, b2 be 6. The reason I chose h equals 2, notice this is one of those examples where I said sometimes a number not on this list, 0, 1, and -1, and roots are another special value. It's a special value. The reason h equals 2 is a nice easy number to plug in is because when we multiply by a half, 1/2 times 2 is just 1. Very easy to multiply by 1. 4 plus 6 is 10. So then a would be equal to 10. So if I plug in a equals 10, b1 equals 4, and b2 equals 6 into one of these answers, it's got to give me an h of 2. So 2 times 10 divided by 4 plus 6, which is equal to 20, over 10, which is equal to 2. This one would give me a 1/2. Notice that choice 3 is actually the reciprocal of choice 1. Choice 4 doesn't even have the right operations in it, but this gives me 1/2 of 5 minus 10, which is a negative number, right? Less than 0. That's not h. And then if I plug in this one into this one, I get 1/2 of 10 times 4 plus 6, which is 5 times 10, which is equal to 50. The height would be 50, which is not correct. So again, by test-taking strategies, choice 1 is the answer. Number 18, the 3 functions are given below. F of x equals negative absolute x plus 2, that plus 7. G of x equals x minus 3 squared, in parentheses, plus minus 4. And then h of x is a table function, which actually looks quadratic. And then which functions have the same y-intercepts? So you do need to know this, like if you have a graph, the y-intercept is where the function crosses the y-axis. So can you use your calculator on this one? Absolutely. Can you do this one by pressing y equals? Absolutely, except really for this one, technically you could use your calculator. Notice here that at the y-intercept x equals 0, always at the y-intercept x equals 0. This one, technically you could do it on the calculator because there is a way to graph points on the calculator, but I might as well just read the y-intercept when x equals 0, y equals 3, negative 3. So for the other ones, if I plug in x equals 0, I get f of 0 equals negative absolute 0 plus 2, absolute plus 7. And g of x, g of 0, is equal to parentheses 0 minus 3, that squared, minus 4. And I could plug those numbers into the calculator, or I could press the functions into the calculator. The benefit of putting the functions into the y equals is that it's easier for most students to put that correctly than it is to put numbers correctly. For some reason, students just insist on just making parentheses and things disappear when there are numbers only. They make up rules that are just false. And the rule almost invariably is, I don't need parentheses. Your second grade teacher through your ninth grade teacher has been saying to you for years that that parentheses are required in many situations. But students, in this weird insistence of not writing parentheses, just kind of erase them, right? If a parentheses is there, you don't ask, should I eliminate it? And then just eliminate it without answering the question. You ask, can I eliminate it? And does it help? Because when you ask the word can I, ask the question, can I? Often the answer is just no, and you realize that it's no. The second is, if you don't know, then don't erase it, because then it doesn't help. And of course, if you can, which again, in most cases you can't, sometimes it just doesn't help anyway. So don't. So plug these numbers into the calculator, and I get negative 2 plus 7, and that's equal to 5. And this one is equal to 3 squared, negative 3 squared minus 4. If you don't use parentheses, you get this one wrong. This is positive 9 minus 4, which is equal to 5. So I see those same y-intercept for f and g. And so then this one is the answer. There we go. Number 19. The sum of x plus 7 squared and x minus 3 squared is it 2x squared plus 58, or 2x to the 4th plus 58, or 2x squared plus 8x plus 58, or 2x to the 4th plus 8x squared plus 58. Now, I see that this is a quadratic, and this is also a quadratic, and I do need to know that the word sum means plus. All right, that is an inescapable fact. The word sum means plus. Since this thing says plus, I'm going to add these two functions. If I add two quadratics, the result is either a quadratic or lower degree. It could be a quadratic because you're adding quadratics. It can't be higher degree. Physically impossible to add variables and suddenly get a higher degree. Then it can be lower degree if the x squareds eliminate, but the x squareds don't eliminate here because we're adding a positive x squared and a positive x squared. So this is going to be a quadratic guaranteed, not a quartic. Choice 2 and choice 4 are eliminated. We have a passing problem. Okay. Can this one be done on the calculator? Again, pressing y equals, yes. So we see on this test, pressing y equals can get us a passing grade just by itself. But can we do it another way? I'm going to do it by taking an easy test value. Unfortunately, I already tested plugging in 0. Unfortunately, it doesn't eliminate any answers. But if I plug in 1, which is not the easiest number in my opinion to plug in, by the way, I think negative 7 or positive 3 are easier numbers to plug in because those are roots. Those are going to give me the answer. Actually, I am going to plug in a y. This one will do it. And I know that because my work, and I did that in my work. If I plug in 1, if I plug in 3, then I get 3 plus 7 squared, which is actually also a nice number, and a 3 minus 3 squared, which is also a nice number. So I got an easy number that is also somewhat rare. Let's see if this helps. I can't guarantee it. I'm a little nervous about it. But let's see. I get 10 squared plus 0 squared is 100. 100 plus 0, which is equal to 100. And if I plug in 3 into both of these, 2 times 3 squared plus 58 is 9 times 2 is 18 plus 58. Doesn't end in a 0, so I know that's not the answer, but just for completeness, 76. And then this one gives me the same 76 plus the 8 times 3. So 76 plus 24, which is 100, giving us that as the answer. How do we do this on paper? I would expand both by the box method. X, 7, X plus 7. And then the same thing, X plus 3, X plus 3. Fill in the box with the products and then add all the terms. Number 20, the product of 2 radical 10 and 3 radical 2 is it 12 radical 5 or 5 radical 20 or 24 radical 5 or 5 radical 12? Believe it or not, it's not necessarily a bad strategy to make an estimate of this answer. If you make an estimate of this answer, then, like, for example, 10 rounded down to a radical 9 is 3. 2 times 3 equals 6. And this 3 rad 2, rad 2 is around 1.4. If I round it up to 1.5, then 3 times 1.5 is 4.5. And then if I multiply 6 times 4.5, then I get 24 plus 3 is 27. So the answer has to be close to 27. And notice, by the way, there's a little clever thing that I did that is a way bigger strategy and actually helps with calculus problems. It's a way bigger and better strategy than it seems. I know that I have to multiply these two numbers. If I shrink one and shrink the other, the product shrinks extra. If I grow one and grow the other by estimating, the product grows even more. But if I grow one and shrink one, then the product stays closer to the same. So I shrunk radical 10 down to radical 9, and then I increased the radical 2, which is 1.4 and change, to a 1.5. The product is going to be very close to 27. And so if I do that estimating for these, this is slightly bigger than 24. 12 times 2, 24. This radical 20 is around 4.5-ish, between radical 16 and radical 25, 4.5. Multiply these two numbers, this is around 22.5. I suspect that choice 2 is a little bit too small. Choice 1 is looking pretty good, slightly bigger than 24, and the answer's got to be close to 27. And then 24 radical 5 is greater than 24 times 2, which is equal to 48. This is way bigger than 27. And then 5 radical 12, this is, if I round 5 times 3.5, this is around 17.5, is way less than 27. So that does eliminate choice 4 and choice 3, and I suspect that choice 2 is wrong, so I'm liking choice 1. And now, how do I do this on the test? Again, test-taking strategy, because unfortunately, some of these skills we're going to get to practice them on a part 2. But because we're focusing on test-taking strategy, I'm going to multiply these on the calculator. 2, and that's the biggest deal. The only thing that you need to know is that the word product means multiplication. That's the only thing that you need to know, that the product means multiplication. 2 rad 10, that times 3 rad 2 is 26 and change. 26.83, which I said really close to 27. Surprise, the math teacher knows something. And then if I plug in to choice 1, I plug in 12 radical 5, and I get the same exact answer. So choice 1 is the answer. 21, when 6x cubed minus 2x plus 8 is subtracted from 5x cubed plus 3x minus 4, the result is, so now we're subtracting polynomials, the result is x cubed minus 5x plus 12, or x cubed plus x plus 4, or negative x cubed plus 5x minus 12, or negative x cubed plus x minus 4. So here's a way to simplify the problem. One of the nice test-taking strategies is if you solve a simpler problem and then plug in the more difficult stuff into the same method. What if I said if 6x cubed is subtracted from 5x cubed? That means 5x cubed minus 6x cubed is equal to, well, 5 minus 6 is -1. You're not expected to know all arithmetic, but might as well use it. 5 minus 6 is -1, right? So 5x cubed minus 6x cubed is -x cubed, okay? And so the answer is going to have a -x cubed. So these answers are looking good. These answers are already wrong. So choice 1 and choice 2 is wrong. Wrong. So we got a passing problem already, just by solving the simpler problem, 5x cubed minus 6x cubed. If I plug in an easy number to plug in, like x equals 0, then that's gonna, if I plug in x equals 0, that'll also eliminate the incorrect answer. So easy number to plug in. Plug in x equals 0, and I get, I get 8, and I get a -4, and subtract the first one from the second one. -4 minus 8 is equal to -12. And the only one that gives me 0, 0 minus 12, that's the only choice that gives me -12 is choice 3. Choice 4 would give me a +4. So with test taking strategy, I've eliminated all the incorrect answers. How do I do this on paper? Just because I feel like I gotta be complete. On some, at least most of them. Most of them I've been complete. Some of them I've just focused on the test taking strategy. But it's 5x cubed plus 3x minus 4 minus parentheses 6x cubed minus 2x plus 8. Let me zoom into this a little bit. Now that I have the numbers. 8. And I could just, to get rid of the parentheses, I could distribute a 1 in front and a -1 in front, okay? And I get 5x cubed plus 3x minus 4. And then I distribute a -1, and I get minus 6x cubed minus a -2x plus 2x and minus 8. And then I could just go one term at a time. 5x cubed minus 6x cubed is already confirmed -x cubed. Oh, and by the way, could you do this one by y equals? Yes. Just plug it into y equals, see which one gives you the same y coordinates. Then I get 3x minus 2x, no, plus 2x, because it's a minus -2x plus 2x is equal to 5x. And then also -4 minus 8 is equal to -12. So the answer is -x cubed plus 5x minus 12. Which was, in fact, what we said, choice 3. Number 22, 3 relations are shown below. One says the relation 0, 1, 1, 2, 2, 3, 3, 4. The Roman numeral 2, the relation 3 to 3, 4 to 4, 5 to 5, 6 to 6. And then step 3, Roman numeral 3 is the step function given over here. Which relations represent a function? So a function has to satisfy the vertical line test. Meaning that the x-coordinates can't have two different y-coordinates. Two different y-coordinates. The x-coordinates cannot have, can't have two different y-coordinates. And so if I look, the x-coordinates only appear once. So this is a function. And choice 2, 3, 4, 5, 6, the x-coordinates only appear once. So this is a function. So any that say Roman numeral 1 and 2 could be correct. 1 and 3 only, missing 2. So that one's not correct. Choice 3 is missing 1. Missing 1. So that's not correct. And then choice 4 is not missing 1, not missing 2. So it's now we have to check if choice 3 is a function. And this one's clever, because it tests whether a lot of students know what this open circle or closed filled circle mean. You do have to know the open circle is the end point, but it's not included in the function. Okay? Endpoint, open circle, not included in the function. And then a filled circle is an endpoint and is included in the function. Or relation. I should say in the relation. I'm going to cross out the word function and put relation. But functions are relations where the x coordinates don't repeat. So we just have to check with the vertical line test. Now, how do we work the vertical line test? We have to check if the vertical lines cross the function at most once. So this is where we could start to fail. And I see here that this crosses 2 points, but this one's filled. And this one's open. So this vertical line crosses just once. It does not cross a second time at that bottom filled, a bottom open circle. So does pass the vertical line test. So far we're good. Every vertical line here, same thing here. One filled circle. But this one is open. So there's no conflicts there. And then again here, this one's filled. And this one is open. And that's it. So the Roman numeral 3 passes the vertical line test. So Roman numeral 3 is a function. Number 23, the method of substitution was used to solve the system of equations below. 4x minus 7y equals 7 and x minus y equals -1. Which equation is a correct first step when using this method? So x equals y minus 1 or y equals x minus 1? I suspect that one or both of those could be eliminated very easily. But I do see that something seems to be done with these equations to get choice 3 and choice 4. I see if I add the two equations together, I do get 5x minus 8y equals 6. But this is not, that's not substitution. Remember, this is the first step in substitution. That's not substitution. Okay, so what is substitution? Substitution is we solve one equation for one variable in terms of another. And then step 2, we substitute that expression into another equation. So for example, you might want to solve the second equation for x. That seems to be not too difficult. If I add y, I get that x is equal to y minus 1, which looks like choice 1. So choice 1 is actually looking very good. And then what I would do in that case is substitute that into the first equation. I would replace the x with a y minus 1. So 4 parentheses y minus 1, close parentheses, minus 7y equals 7. That's substitution. But notice that that is the first step in the process. What about choice 2? Because a lot of students think that choice 2 is correct. And I just want to be super clear that it's not. And the reason it's not, if you start with x minus y equals -1, if you subtract the x, you got to subtract the x, you get that -y equals -x minus 1. And if you multiply both sides by -1, you get that y is equal to positive x plus 1, not minus 1. So that's not incorrect. That's not correct. And a similar thing happens, we already eliminated choice 4. A similar thing happens with choice 3 as with choice 4. If you subtract the second equation from the first equation, you get exactly this expression. But again, that's not substitution. That would be maybe in the right direction towards an elimination method, but that's not substitution. Okay? So yeah, choice 1 was the answer. Problem 24 In 2009, Usain Bolt, a sprinter from Jamaica, set the world record for the 100-meter dash with a time of 9.58 seconds. It was fast. It was wild when I saw it. His approximate speed in kilometers per hour can be found using which conversion? I'm not going to read all of these because I'm actually just going to go straight to the method. They do ask a similar question in Algebra 2, which isn't quite as simple as this, but the method here is this. Cancel units in the numerator and denominator. And if you find that you arrive at a point where units don't cancel, then that's likely incorrect. And so, for example, here, meters in the denominator, meters in the numerator, minutes in the numerator, minutes in the denominator. We got seconds in the numerator, seconds in the denominator. Now, this is actually an example where the units do eliminate correctly, but the numerator is hours, but the denominator is kilometers, and the units of choice 1 is kilometers per hour. They used to not ask questions where the reciprocal appears, but they do apparently now. So they said kilometers per hour. This is not equal to kilometers per hour. So choice 1 is not the answer. Then I'm going to eliminate units in this one. Eliminate units, the seconds. The meters both appear in the numerator. So meter does not eliminate. Again, it does not eliminate because they're both in the numerator. So that's not the answer. Then I'm going to start canceling units here. I don't see meters. There we go. Meters and meters cancel. Let's see. I see seconds appear in the denominator. So seconds does not eliminate because they both appear in the denominator. Okay. And then meter, seconds eliminate, minute, kilometer, meter and meter cancel, and then minute and minute cancels, leaving behind only kilometer and hour, and this is in units kilometer per hour, which is exactly what we were required, kilometers per hour. It's the only one that even has the right units. And so the way to do this problem is to actually look for the right units. For Algebra 1, for sure. And then if in Algebra 2, they give you a slightly varied version of it that's a little bit more difficult, then you do what you got to do to get that one right. And with that, we just got a perfect part 1. Congratulations, you got all of those points. You got 48 points. Let's see what grade that we got and get some advice, because we are on a test taking strategy kick. We've got 48 raw score points. Now look at our score. Our score is a 73. This is the death knell for the idea that we can pass this Regents by just focusing on the part 1s. Notice if we focus on just the part 1s, well, yeah, we can get a passing grade of 73. But notice we're not playing a game of 0 to 100 if we're focusing on just the multiple choice. We are playing a game of 0 to 73. That's the game that we're playing if we're focusing on only the part 1s. 0 to 73. The maximum grade that we can really get is a 73. So we really do have to focus on the part 2s, 3s, and 4s to really get a grade. A good grade on this test is 1. For those of you aiming for 100, obviously you have to aim focus on the part 2s, 3s, and 4s. But to pass, you don't want to play a game of 0 to 73. That's a coin flip, you know? Practically, or worse. You're like more likely to fail than to pass if you're focusing only on the part 1s. So doing that doesn't work. That's it. Like a 73 is not a good enough grade for us to focus only on the part 1s. And worth noting, 47 and 46 points in the raw score, also a 73. So we are going to focus on the part 2s, 3s, and 4s now. Yes, there's going to be some test taking strategy here too, but the biggest thing here is, of course, that we have to show all work to get full credit. But there is a big test taking strategy point here that is valuable. For all questions in this part, over here, for all questions in this part, a correct numerical answer will, with no work shown, will receive only 1 credit. So 1 credit is greater than 0. It's not full credit, but it's greater than 0. And 1 credit is half a multiple choice question. So we said that if you get half the multiple choice plus 5 points here and there, if you could figure out how to do the question on the calculator and you don't know how to translate it to work on the paper, do it on the calculator. Just write down the answer. You'll get credit. 1 credit. And you're really closer to passing. Not only that, you're closer to getting a 73 or a 75 or an 80 or whatever grade you're aiming for, even a 90. Of course, 1 point only, and that's it. You're not going to get a 90. But if you are hovering around a 90 and you need a point on a question that you just don't know how to do, get your 1 point if you're able. So for example, on this one, solve the equation 1/6 parentheses 4x plus 12 equals 9 algebraically. You could do this one by literally just plugging in numbers and just guessing and checking. I'm gonna go ahead and put in a fraction here. If you struggle with when to use parentheses, 1/6, and I know like a 0 is not big enough for a 9, so I'm gonna guess a number. Oh, I don't know. I'm also gonna guess a multiple of 6 because 6 is I'm gonna end up having to divide by 6. So I'm gonna start with a multiple of 6. It might not be a multiple of 6 though, for reasons, but I'm gonna start that way. How about 6? 4 times 6 plus 12. Does that give me a 9? No, but it gives me a 6. So what if I go to 12 plus 12? Why did I go bigger? Because I know the answer had to be bigger. And that went to 12. And so then so how do I go about can I do this by just guessing repeatedly? Yeah, because I know the answer for x has to be between 6 and 12. So then what if I then try 9? Let me delete that O so it doesn't confuse you. 9. And now we're at 8. And now I have to be, so this 10 and 8, and the answer that I'm looking for is 9. So the answer has to be exactly between 9 and 12. And if I put insert 10.5, the number that's exactly between 9 and 12, I get a 9. So if I just write down 10.5, I get 9. And you might think that that's crazy, but it worked, didn't it? Write down 10.5, I just got a point. Another way you could do it, can you do it by pressing y equals? Absolutely, you could do it by pressing y equals. Okay? So you could press y equals and graph it. And graph 1/6 4x plus 12. And graph y equals 9. And then calculate the intercept. I'm probably going to do another one like that later on. So for this one, I'm gonna, since I already gave you a guess and check strategy, I'm gonna focus now on the full and complete way to do this problem. Let's move forward a little bit. Okay. So I'm gonna multiply by 6. I got 4x plus 12 equals 54. Subtract. Now, granted, I have parentheses here. And if you don't know if you could just erase the parentheses, don't just erase the parentheses. Go ahead and put a 1 here and distribute it. If that's what you need to do that. Then that gives you a 4x plus 12 without the parentheses equals 54. Then subtract 12. And this is not an arithmetic test, so 4x equals, be humble. If you need to do 54 minus 12 on the calculator, just do it. 42, and then divide by 4, and I get that x is equal to 10.5 according to my calculator. I have one installed. There we go. And that's a full 2 credit answer. Could you have done this one by working backwards? Yeah. If you wrote in the middle of the page 10.5, and if you did know with 100% certainty how to work backwards from there, like 4x equals 42, 4x plus 6 plus 12 equals 54, 1/6 of 4x plus 12 equals 9. If you just wrote that, they don't know that you wrote that backwards. So you'd get full credit. You'd get full 2 points. So there's a point. I give you one way to get a point, and I give you another way to get your second point, even if you didn't know how to do the problem. Number 26 is the sum of 3 radical 2 plus 5 rational or irrational, and explain your answer. 99% of the time, the calculator gets this right. If you do 3 radical 2, 3 radical 2, radical, there you go, 2, that plus 5, and then math, convert to fraction, to convert to a rational number. 99.9% of the time, this calculator gets this right. There are weird bugs that make certain numbers look like they're rational when they're really just not for a calculator. It's because of the way the calculator does math. But this calculator could not convert this number to a rational number. So if I said irrational, I might get a point. If I give, so I am looking at the grading of the problem. If you just say irrational, but you don't give an explanation at all, unfortunately in this one, that's not a numerical answer. So they're not lying to you when they don't give you any points. However, if you say irrational, but you give a partial explanation or an explanation that's missing a fact, that will do it. Interestingly, the grading here says the full display of the calculator and the word irrational are written, but the explanation is incomplete, missing, or incorrect. That is a shocker to me. I've never seen that before. So in other words, if you wrote 3 radical 2 plus 5 arrow frac equals 9.246264067, that's a point. And I'm sorry, not a point. Then you wrote the word irrational because the calculator didn't convert it into a fraction. That's a point. That's insane to me, but hey, they did it. So that's how to get a point. But that's not 2 points. How can we get 2 points? We actually have to give a proper explanation. So we could say irrational. It's important to know that 3 radical 2, because 3 radical 2 is the product of a rational and irrational number. And so is irrational. If you multiply a number that can be written by a fraction times a number that can't be written by a fraction, the product can't be written by a fraction. 5 is rational because it can be written as a fraction. 5 is equal to 5 over 1. Okay, great. So, and then 3 radical 2 plus 5 is irrational because it is the sum, because the sum of a rational and irrational number is irrational. Okay. There we go. So that's a full credit question. Let's actually, I think this one is worth investigating because we are talking test taking strategies. So it is worth investigating. Let's go for the model response set. This is number 26. Let's see if they, because I have a suspicion that that if you just said it's a sum of a rational number and an irrational number, 3 radical 2 is irrational, and adding irrational with 5 irrational doesn't make it rational, so it's irrational. So that's a weird way of wording it, fine, but it does say 3 radical 2 is irrational, 5 is rational, and the sum of a rational number and an irrational number is irrational. So you don't have to explain why 3 radical 2 is irrational. You don't have to explain why 5 is rational, but you do have to explain why 3 radical 2 plus 5 is irrational. Okay? So you could just say 3 radical 2 is irrational, 5 is rational, and then you could say 3 radical 2 plus 5 is irrational because the sum of a rational and irrational number is irrational, and that gives us full credit for that problem. Number 27, graph h of x equals absolute x minus 2 over the domain -4 to 4. This is highly recommend using your calculator here. Okay, so I'm gonna graph. Now I think I've run out of space here, so I do have to clear some now. Clear this one, let's say absolute, and we learned how to put an absolute value number in the calculator, math number, and the very first option is absolute, x minus 2. Close the absolute over the domain -4 to 4. So I am just going to graph it. I'm going to graph it, and it looks like that. But I can't graph it past -4 to 4. So I'm going to go to the table and go get my y coordinates -4 to 4. I got -4, 6. And I want to be clear. I went -4, 6, and I graphed that right away. But I want to be clear. I just have an I for that. I definitely counted -4, -1, -2, -3, -4, and then up 1, 2, 3, 4, 5, 6. And then the next one is -3, 5, according to the calculator. So clear, I'm just want to be clear here. I'm using the calculator. -2, 4, -1, 3, -1, 3, -2, 2. No, -0, -2. Sorry, 1, 1, and then 0, and then 2, 0. That confirms that. That's right. 2, 0, and then 3, 1, and then 4, 2. Oops. Now, how to connect these? I have to connect these with a perfectly straight line. I don't have a straight edge on the screen, but my software acts as a straight edge. You are required to have a straight edge for this test. So you could ask the question, can this be a jagged line because I didn't use a straight edge? No. If it's able to be, if it's a straight, perfectly straight line, you have to draw it with a straight edge. And if it's not a perfectly straight line, you are not allowed to draw it with a straight edge, because graphs have to mean what they say. The second piece that will lose you points is if your absolute value doesn't look like a V. So it has to look like a V. Number 28. Before I read the question, I've seen this kind of question before, so I'm going to tell you how to get the points before I even read the problem. This question is going to give us some details about, let's see, it's adults, teenagers, and brand A and brand B. It's probably like who uses brand A, who uses brand B type of questions. And here's the thing. There are 9 boxes that we've got to fill in, but I know that there's 4 degrees of freedom because I could have any numbers in the first 4 boxes, and literally any numbers at all, and they don't contradict each other. And once I have those 4 numbers, I can fill out all the other 5 boxes for all 9 boxes. So this problem has 4 degrees of freedom. The problem has to eliminate 4 degrees of freedom. Why is that relevant? Well, one, degrees of freedom is a really important skill that I wish was taught at all, but it's actually not even taught until stats. And even when it's taught in stats, people don't use it in other places. I actually teach them in other places. This problem has 4 continuous degrees of freedom. So if they eliminate the 4 degrees of freedom, the problem is completely solvable. So there's guaranteed to be 4 pieces of information that are given in this problem. The second reason that I'm mentioning that is that in this problem, if the way to get points is if you use those four, if you only give those four pieces of information that they gave, you still get 0 points. But if you use those pieces of information to get any other number, you're gonna get a point. Okay, so here's the numbers that they gave. They said a survey was given to 180 cell phone owners. So the total is 180. Okay, about the brand of phone they owned. The results showed that 59 adults owned brand B. So 59 adults owned brand B, and 32 teenagers owned brand A. I still have 0 points because this is just the numbers that they gave me. 32. That's 3 out of the 4 degrees of freedom eliminated. 32. And then of all the people surveyed, 40% owned brand A. So to eliminate this fourth number, I actually have to do a calculation. Let me go to the calculator, which cleared itself. Interesting. And I have to do 40% of the total. So I could do this on paper technically. 10% of 180 is 18. 40% is that times 4 is 72. But I'm going to do it on the calculator. 180 times 40 over 100, or 0.40, is 72. So 72. And I still have 0 points. If I fill in any other number, then I get another point. So I'm going to focus on getting a different number. Am I? Yes. I did it differently on my paper, but I'm going to focus on getting a different number just to re-emphasize the point. I see that the total for brand A is 72, and the total is 180. So the total for brand B is, oh, and by the way, this is one example where you don't actually have to show work, because this showing work is arithmetic. This is not an arithmetic test. You do not have to show the arithmetic. You have to show the algebra. So, but I'm going to show the work to show you how I did it for the purposes of the video. The number of students in the number of individuals in brand B total is the total 180 minus the total in brand A, 72, which is equal to, I'm going to write this in green, this color now, which is equal to 108. Now I have a point. I have a point on the test. But now the only way to get my second point is to fill out the entire rest of the table correctly. So for brand A adults, I noticed that the total for brand A is 72. So if I subtract from that total the number of teenagers that use brand A, 32, well, 72 minus 32 is equal to 40. And I still just have 1 point. Now, the total for brand B is 108. And the total adults for brand B is 59. So if I subtract the 59 from the 108, 108 minus 59, well, that's equal to 49. And I still only have 1 point. Now, if I go horizontally, I see that the number of adults in brand A is 40 and the number of adults in brand B is 59. So the total adults is 40 plus 59. And that's equal to 99. And now you see that there's actually 2 ways of getting this number here, 180. 180 is the total, and 99 is the total adults. So if I subtract the total adults from the total, 180 minus 99, that's equal to 81. And in fact, if I do 32 plus 49, that's also equal to 81, and that confirms that I did this problem correctly. Pretty sweet. And in fact, there's actually an immense number of ways to do this question. So if you just get notice, if you get any piece of information, you actually, using the other numbers, you get full credit. The only way to get all the other numbers and still lose some points, like for example, if you calculate the brand A total here, that 40% number, which causes you to use a calculation to eliminate that fourth degree of freedom, if you get that number wrong, that's a point lost, which means you'd have to get all of the other numbers basically to get a point. All of the other numbers, even using that incorrect answer, to get a point. Okay? But if you use those four numbers, the 72, 32, 59, 180, to get a single number, that's a point. Number 29, determine the eighth term of a geometric sequence whose first term is 5 and whose common ratio is 3. The eighth term of a geometric sequence whose first term is 5 and common ratio is 3. Now, you can do this one by formula. If we look in, there is a formula sheet. There is a formula for a geometric sequence. So you could use the formula for a geometric sequence. A sub n is equal to a sub 1 r to the n minus 1. Okay? And I'm going to write this down on the side. A sub n is equal to a sub 1 r to the n minus 1, where r is equal to 3, n is equal to 8. So you can do it that way, but because we're focusing on test-taking strategy in this case, this test does not require you to use a formula to get this answer. You are allowed to get this answer via, let me scoot my rocking chair a little forward. You are allowed to get this answer by using arithmetic methods. So for example, you are allowed to say 5 and then comma, 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 comma. That's the eighth one. 1 is 5, 2, 3, 4, 5, 6, 7, 8. Okay, and then you need to know that a common ratio is 3, so I'm going to multiply by 3 times 3 times 3 times 3 times 3 times 3 times 3 and times 3. And I'm going to show you that on the calculator, this actually isn't that hard to do. If we have our calculator open, if you press 5, press enter, and now you just put times 3, it does answer times 3, and it lists all the numbers for you. Times 3, times 3, times 3. So let's write some of these numbers down. 15, let's go for a different color. 15, 45, 135, and then 4 more numbers. 1, 2, 3, 4. 405, 1225, 3645, and finally 10935. 10935. So the answer is 10935. And that is an acceptable way of doing the problem. For teachers and students who have a healthy dose of skepticism, here is an example of the grading sheet of a student who did this by listing them, showed the work. I wrote the times 3, right? So, and then I wrote the last number, 10935, and I circled 10935. They didn't even circle 10935, and the number of points they get is 2, which is the maximum score for this problem. So that confirms that this is a viable way of doing this problem. With that, we'll go to number 30, using the method of completing the square, which means we have to use that method and that method only. Express x squared plus 14x minus 28 equals 0 in the form x minus p squared equals q. Interestingly, if you had a plus in there instead of a minus, they still give you full credit. But I'm going to put the minus in because I saw a test in Algebra 2 where they didn't allow that. And in fact, I said, I think it was Algebra 2, and if it wasn't Algebra 2, it was Geometry, and if it wasn't Geometry, it was Algebra 1. But I gave a wag of the finger to the test makers because we understand that we're allowed to simplify minus or negative. And they didn't allow something along those lines. So on this question, I'm going to write it the same way they told us to write it, even though they allowed a plus. Use the method of completing the square. So how do I complete the square? It's a procedure that you could follow exactly as this. You write the value of b. So you check that a equals 1. So write in standard form equals 0. Check that a equals 1. Then you subtract c, or eliminate c. I'm going to say eliminate c. So I'm going to do plus 28, plus 28. And I get that x squared plus 14x is 28. You eliminate c, and then you write, so that's done. Write b equals, b over 2 equals, and parentheses b over 2 squared equals. So b equals 14, b over 2 equals 7. You could use your calculator to do 14 over 2 equals 7. And b over 2 squared is 7 squared is 49. And then plus 49 and plus 49. And we get that x squared plus 14x plus 49 equals 28 plus 49 is 77, according to the calculator. Okay? And then why did we do that? We used this b over 2 squared to write this expression. Now this expression, this whole big expression, is a completed square. The x squared plus 14x plus 49 is a completed square, and we are actually now going to use this 7 to complete the square. We get that parentheses x plus that 7 plus 7 squared equals 77. Okay? Now, technically, we're done in terms of the grading, but I did see a test where they literally, they took away a point in a certain situation where, now I remembered the problem. Actually, now I remember the problem. They said to write the problem in a plus bi form. And there is a standard thing that people do where they often put the I between a number and a radical, or they put the I in front instead of in front of the second number, or if it's a subtracting of a number, they'll put a minus. And they whatever it is that they did, they didn't allow those basic things. They literally forced you to write a plus, and then b, and then I in that order. And if you did it in another standard way, very standard way, they took away a point. Very frustrating for me. So because of that, even though they technically allowed 2 points for this answer, I'm going to do exactly what they said. They said x minus p squared plus q. Plus 7 is the same thing as minus a negative 7. So I could replace this as x minus negative 7 squared, and that's equal to 77, following the rules that they asked me to follow. And that second answer is obviously also a fully perfect grade, and we actually just got a perfect part 2. We aced part 2 of this test and part 1. Let's actually see what we got. Actually, we know what we got. We got 1 point less than an 80. So we don't have an 80, we have a 79. With all of that work, we got a 79. So is it worth focusing on the part 2s, 3s, and 4s? Absolutely. Because we don't even have an 80 yet. But we are about to get an 80. Same deal as the previous one. Numerical answer will give you 1 point. Okay. And if you show correct work, you can get a point. But do understand, if the function is linear, you got to use a straight edge, and if the function is not linear, you are not allowed to use a straight edge. So that said, number 31, graph f of x equals negative 1/3 x squared plus 4 on the set of axes below. I'm going to, do you have to graph as all the points that they want you to graph, like, or every single point for every single integer? You actually do not, okay? But what I'm going to do, press y equals, negative, I'm going to do the fraction. I'm actually a fan of the fraction, n over d, 1 over 3 times x squared, that plus 4. Okay, I'm going to graph that. So now I know what the graph should look like. It's an upside down parabola. It's going to cross the y-axis. And I'm going to also graph what I know to be integer points. I'm going to go to the table, and I'm going to use the scale that each box represents 1 so that I don't have to label. This is already labeled f of x, which is great. I see 0, 4. Let me do it in magenta here. 0, 4. And I see integer points. Where else? Oops. Where do I see integer points? I'm going to go upward. I see negative 3, 1. -3, 1. And I see, keep going, -6, -8. -6, 1, 2, 3, 4, -8. I did count. I promise you. I just happen to have a good eye for it. And then it goes beyond -8. So here it passed. So -37/3 is past -10. So it's going to have an arrow going here. And I'm going to actually draw this part. So can I draw the other ones? Yes. So one benefits of writing it in a fraction is that students who struggle with parentheses don't have to struggle with parentheses. A drawback, though, is that it writes it as a fraction, and we kind of want decimals. So I'm going to change the 4 to a 4.0 because that turns it back into a fraction. I'm sorry, turns it back into a decimal. And I am going to graph some of these non-integer points. Let's see. At -7. There we go. -4.33. This is just to be a little bit more exact. And then -1.33. And then and then 1. And then 2.67, 2 1/3, 2/3. And then 3 2/3. And then it actually repeats. So if I keep scrolling on the calculator, it repeats. And that point there, that is an integer point. And then it goes down. So now I'm not going to use a straight edge because I'm not allowed. So I go slowly, go through these points. Do I need to do it like perfectly perfect? Actually, not perfectly perfect. But your dots, if they're on an integer point, they have to be on the intersection of two lines. That's the big deal. I'm going to remove the calculator now. My curve got a little jagged over here. That's actually okay. That's smooth enough. The big things is notice that the peak is definitely here. It goes a little bit. Let me erase this a little bit if I want to fix it a little bit. Because I want to know that the peak is at that point. Okay. This is a full 2 credit problem. About the arrows, do you have to put the arrows? The rule is if the function continues, you have to do one of two things, and I train my students to do both. If the function continues beyond the end, you have to either get to the end or you have to draw arrows. And I train my students to do both because now it goes from memorizing when to put arrows and when not to an understanding that the function continues. And so I actually ask my students to do both. Second, if the function doesn't continue, then you actually have to end. And you have to put an endpoint and just stop. Okay, and there's a lot of examples. Now state the vertex of this one. You actually can just state the vertex. They don't actually expect you to calculate it. You could say 0, 4. And that's full credit. You could also calculate negative b over 2a is the x-coordinate. -0 over 2 times -1/3 is 0. And then plug in a 0 and you get -1/3 times 0 squared is 0 plus 4 is 4. So that's the vertex. So there is one more part, but before I even go to the one more part, this graph, if you just do it neatly, it's 2 points. Notice about focusing on the part 2s, 3s, and 4s. Like if you graph this neatly, which we did using the table, you get full credit for that graph. That's 2 points. What happens with a lot of students is they decide to draw the points, but not even be accurate with them. Then they draw a curve and they don't even bother making sure that the curve is in the right place. And out of 3 points, they get 2 or 1 or even 0 points, which is such a bad way to lose points, especially on such an easy problem. And then for the vertex, if you just state the vertex, they don't expect you to calculate the coordinates of the vertex. They just said state it, and that's good enough. So you could look at the graph and see that the vertex is at 0, 4. Okay, I'm going to erase that little box that I made. It's not letting me just grab the box, so I'm going to erase the box manually. Okay. And the last piece, the graph is 2 points. This vertex is worth 1 point, and then the equation of the axis of symmetry is also a point. Each one of these is really easy places to get a single point if you didn't know how to graph it correctly. For example, the vertex could also be gotten on the calculator by calculating the max of the function. State the equation of the axis of symmetry of the function. Well, the axis of symmetry is the y-axis. So The axis of symmetry, again, is negative b over 2a. X equals negative b over 2a, which is negative 0 over 2 times negative 1/6, which is 0. So x equals 0 is the axis of symmetry. That's a full 4-point problem. And even just good details on the graph got us to an 80. More details got us higher. Number 32. Vince wants to rent a canoe while he's on vacation. The canoe rental company charges $18 for the first hour and $7.50 for each additional hour. X. If Vince has $78 to spend on renting canoe, write an inequality in terms of X that models the situation. And then algebraically determine the maximum number of hours that Vince could rent the canoe. So there's an important skill that we do need you to have for Algebra 1. So I'm going to state it as the skill is needed, and then you'll know it for geometry and Algebra 2 and then future classes as well. A lot of students don't know this, and I'm not sure why, but we'll know it now. If it costs $7.50 for each additional hour, X. So X is the number of additional hours. So 1 additional hour, $7.50. 2 additional hours costs $7.50 times 2. 3 additional hours, $7.50 times 3. 4 additional hours, $7.50 times 4. So how much do X additional hours cost? We follow the pattern. 5 additional hours, $7.50 times 5. So X additional hours, $7.50 times X. So the cost of additional hours is equal to $7.50 times X. And then he has, so the first hour cost is equal to 18, okay? And then it says that if Vince has $78 to spend, so the max cost is equal to 78, and so the cost is less than or equal to 78. And so what's the cost? The cost is the cost for the hours plus the first hour. So 18 plus 750x, that's less than or equal to 78. Now, technically, this is also less than or equal to 0. They don't require that. When I was a kid, they did require that. And for some reason, they stopped requiring that because the cost can't be negative. Why they don't require it, I don't know. However, I have noticed that students who cheat tend to have that 0 less than or equal. And how do they cheat? They use AI. Don't use AI on this test. Don't figure out a way to use AI on this test. Oh my God. You'll fail because they'll see that you used AI, and instead of getting a 55 or a 58 or 62, whatever you wanted to get, or you wanted to get an 80 but you got a 78, instead of getting whatever grade you wanted, you get a 0 and maybe expelled. You might get expelled. Like, that's actually grounds for expulsion. So this 18 plus 750 times X is 78. They said to algebraic determine the number of hours Vince could rent the canoe. So we have to solve the second inequality. So X has to be greater than or equal to 0. We could say that. But 18 plus 750x less than or equal to 78. We're just going to solve this inequality via the same way we solve an equation. Minus 18. Minus 18. We get 750. X is less than or equal to 60. And we divide by 750. Divide by 750. X is less than or equal to 8. And so, where do students get trapped here? Well, because X is the number of additional hours. So the max total hours. So, and actually, yes, X is greater than or equal to 0. So the maximum number of hours then, remember, because he paid $18 for the first hours, is equal to 1 plus 8, and that's equal to 9. Number 33, graph the following system of inequalities on the set of axes below. So this one we actually have to label the inequalities because they're both straight lines, okay? They're both straight lines, so we do have to label both inequalities. We have to also make sure that the first inequality is labeled with a dotted line and the second inequality is labeled with a dashed line. This one can be done largely on the calculator though. The first one's already solved for y. If the second one is not, but if we add 2x, we get that y is less than 2x plus 5. And if we actually go to the calculator and graph those, can we graph those? Yes. I don't know why the calculator decided to not put a less than or greater than symbol in there, especially since they have the capacity. But if you press enter and change the line. So what did I do? Let me just clear. Press y equals. If you go to the y2 or y1, whatever, go to the left. Go to the left and you get here. You press enter. Don't bother changing the color, but if you change the line to this, there's a few different options and some of them are cool. But the greater than or less than symbol do look similar, but notice that the greater than symbol is like a triangle that looks like this, and a less than symbol is a triangle that looks like that. The reason they use those symbols is that the symbol is literally graphing under a line, and which is a less than symbol, and this one is graphing over a line, shading over a line, which is a y greater than symbol. But they do vaguely look like the symbol, the inequality symbols. They do. The less than symbol looks like that. And then the less than symbol on the calculator graphing utility looks like this. And then shaded in. And then the greater than symbol looks like that versus a greater, like a symbol that looks like this and then shaded in. So there is a vagueness, a vague look to them that almost looks like the symbol. But I do think that they have enough resolution on the calculator. They should abandon those symbols and just put the correct one. I don't know why they don't. So the first one is y greater than or equal to negative 1/2 x minus 3, and press enter and enter. Negative 1/2. I'm gonna put it this way. Negative 1/2 times x minus 3. And then the second one is a less than symbol. Now, the calculator doesn't know the difference between greater than and equal versus less than and equal. So you have to know the difference. Okay. So y is less than 2x plus 5. And I'm going to graph those. And it can graph these inequalities. That's pretty cool. Calculator speed. Go back to 200%, which graphs it a little bit faster. And so this is what your graph should look like. Okay? But now the difference is, do we put dotted lines or solid lines? So the first one, I'm going to minimize this now. The first one is a solid line. And then the second one is dashed. Why solid versus dashed? The solid implies that the points on the line are in the solution set. And then the dashed implies that the points in the line are not in the solution set. So, and let me actually go to the table of values. So the first inequality is in red. So I'm gonna, even though I wrote in red and wrote in black here, and the second one is in black, I'm gonna draw this one in red, and I'm gonna draw the second one in black. It's gonna be dotted. There you go. So I got some points here. Let's see. From negative 10 to 10. So negative 10, 2. Negative 8, 1. Negative 6, 0. Negative 4 are negative 1. So I see a pattern. Down 2 over 1. Down 2 over 1. Down 2 over 1. 0, negative 3. So that confirms that I'm on the right track. And this should be 10, negative 8. Let me confirm. 10, negative 8. Good. Okay. And now this inequality has to get a solid line. And it's shaded above. So y is greater than this function, greater than or equal to. This is shaded above. And so I'm going to shade above this line. Okay. Good. And I'm going to label this one y greater than or equal to negative 1/2 x minus 3. Okay. Now the second inequality, I see that the first point that's on the graph is 2, 9. 2, 9, 2, 9, and then it goes down. 7, 5, 3, 1, 7. So 0, 5. Confirm that I'm on the right track so far. 3, 1, negative 1, negative 3, negative 5, negative 7, negative 9. So it should be negative 7, negative 9. Oops, wrong way. Negative 7, negative 9. And so I did this correctly. Now this one, you still have to use a straight edge, but unfortunately, this software does not draw dotted straight lines. So I have to manually draw the best that I can straight line, but you are required to use a straight edge. Go up the diagonal. Notice that I'm crossing the points whenever I can. And this one's a dotted line. Okay. And then this one is because y is less than 2x plus 5. This is shaded below. So I shade below. Okay. Now states the state. They don't say to label the region S, but that you can. They don't take away points if you label the region. But they do say to state the coordinates of a point that is in the solution set of the system. So if they told us to label it, I'm gonna go ahead and label it. Which I'm gonna use this Sharpie. Label this as a big S because both regions are shaded. Now, what points can I select? I could select any points, any points that are in the doubly shaded region. So I'm going to choose, how about the point 0, 0? The 0, 0 is in both regions. And I stated it, and it says to justify it. Now, I have to somehow justify it. Justify doesn't require words, but I don't know how else to justify this one except with words. Oh, no, that's not true. I could plug in 0, 0 into the inequalities and confirm that they're both correct. But I could say because 0, 0 is in both shaded regions. Oh, and I have to label this inequality. Y greater than. Y greater than. Oh, no, so y minus 2x. Minus 2x is less than 5. There you go. Now that's 4 points. Okay. And now 2 points on the next problem, on problem number 34, will give us a 90. Notice that we are on problem 34 out of 35, and we still don't yet have a 90. So if you are the kind of student who's aiming for a 90, the test taking strategy benefits that we learned are helpful because they will allow you to eliminate answers that you know are wrong, that you know are wrong or you think are wrong, or even look funny for the problem. And that's a big strategy for process of elimination. Then for part 2, 3, and 4, the test taking strategies also allow you to get individual single points when you don't know how to do the problem, but they also allow you to work backwards or solve a simple problem to be able to get the points that you want, right? So no matter what your grade is, it's worthwhile to learn these test taking strategies. Number 34, using the quadratic formula, solve x squared minus 6x plus 3 equals 0, express the answer in simplest radical form. So the radical has to be fully simplified, but other things don't. Okay? So here, this is a quadratic in standard form equals 0. We have a equals 1, b equals -6, and c equals 3. And now you may be wondering, does this test give us the quadratic formula? And let's find out. Here it is, the quadratic formula. It does give us the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And it gives us that. And so all we have to do is write it correctly. Or if we happen to memorize it, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So now we plug in the numbers that we have. A equals 1, b equals -6, and c equals 3. We get x equals negative of -6 plus or minus the square root of -6 squared. Do you need parentheses? Absolutely. But if we ask, can I and does it help? Can I use parentheses? Yes. Does it help? Yes. Are they required? Actually, yes. Can I not use parentheses? The answer is no. But suppose you don't know, then use parentheses. Okay? Minus 4 times a is 1 times c is 3. All of that over 2a, 2 times 1. Now, this is not an arithmetic test. This is an algebra test. So you are allowed to go into your calculator and let the calculator handle the vast majority of the arithmetic for you. So, for example, suppose you didn't know that -6 was 6. Negative parentheses, -6 is 6. And so this is equal to 6 plus or minus a square root. And do you have to know how to simplify the stuff inside of the radical? No, you could actually do -6 close parentheses squared minus 4 times 1 times 3, and you get 24, square root of 24. All over 2 times 1 is 2. And believe it or not, this is most of your points. But since they said simplest radical form, you do have to simplify the radical. And so now let's talk about how to simplify the radical. We have to look for the perfect square factors of radical 24. So, and I'm going to minimize the calculator at this point. So radical 24. I know that that 4 is a perfect square factor of 4, so I go radical 4, and the factor pair is radical 6. And radical 4 is equal to 2. Radical 6 does not have any non-trivial perfect square factors. Only perfect square factor is 1. So we are done simplifying the radical 24. It's equal to 2 radical 6. So this is equal to 6 plus or minus 2 rad 6 over 2. They said simplest radical form, so this is full credit. However, if they just said simplest form, you would have to know to divide by that 2. So I am going to continue dividing by that 2. So again, this is full credit. But I am going to continue by dividing by that 2. And 6 divided by 2 is 3, plus or minus 2 divided by 2 is 1, radical 6. And so that's also full credit. Either one of these is full credit. And we just got a perfect part 3 and are about to ace this Regents. Seriously, I want to thank you for getting to this point. And you should actually congratulate yourself to getting to this point, because honestly, putting in the work is what gets you the higher grades. And you have made the decision to watch this video to get the highest grade that you can. So I really appreciate that. I believe in your abilities to do it. I know you could do it. And I want to thank you for watching this video. If you do need any tutoring, contact your parents. Tell your parents or guardians to go to JuanTutors.com. And I tutor there. I have a whole bunch of tutors who work there too. But number 35, our very last problem. I'm getting stoked. We're about to do this mic drop. The problem says that Cameron sold hot dogs and sodas at a concession stand. He sold a total of 25 items for $45. And a hot dog sold for $2.25 and a soda sold for $1.50. All prices include tax. If X represents the number of hot dogs sold and Y represents the number of sodas sold, write a system of equations that models the situation and then determine algebraically the number of hot dogs Cameron sold and the number of sodas he sold. And then a customer has $20 to spend on concession stands. Determine and state the maximum number of hot dogs he can purchase if he buys 4 sodas. And that'll be the problem. Okay? So how do I do this problem? I actually create a word equation and convert that into a algebraic equation. Okay? So so they said that the number so that was a lot of information. Should you take in all that information all at the same time? No. Should you read the problem first? Yeah. But I think so. But let's actually now go through the problem and process the information by rereading it. It actually is normal to reread a problem up to 5 times. Normal. In fact, if you're reading it less than that many times, it's likely that you might be not doing enough work. So he sold hot dogs and sodas at a concession stand. He sold a total of 25 items for $45. And so they're mixing the information. So we're going to create an equation for number of items. Okay? Okay? So the number of hot dogs plus the number of sodas equals the total number of items. There's an equal sign there. Okay, so the number of hot dogs is X. X plus the number of sodas, Y, that's equal to the number of items is 25. So we already have a point out of 6 on this Regents. Okay. The second question is, well, how much did he sell them for? So this is the cost of items. Okay. So the cost of a hot dog, cost of hot dogs plus, and I'm running out of space here, so I'm going to have to zoom in a little bit. And I'm going to go a little bit out of the page, I think, for the purposes of clarity. The cost of soda equals the total cost. Good. Okay, so now the cost of of all the hot dogs. This is something that you need to know. Again, what I said earlier before. So if one hot dog sells for $2.25, then 2 hot dogs sell for 2 times $2.25. 3 hot dogs sell for 3 times $2.25. 4 hot dogs cost 4 times $2.25. So if you get the number of hot dogs, multiply by the $2.25, you get the cost of all the hot dogs. So how many hot dogs are being sold? X hot dogs. So X times $2.25. Plus the cost of all the sodas. So a single soda costs $1.50. 2 sodas cost 2 times $2.50. 3 sodas, 3 times $2.50. 4 sodas, 4 times $4.50. So Y sodas, Y times $1.50. $1.50 Y, and that's equal to 25. Nope, 45. $45. And so those are our 2 equations. We got X plus Y is 25 and 2.25X plus 1.5Y is 45. And that's 2 points out of 6. Phenomenal. Now we got to determine algebraically the number of hot dogs Cameron sold and the number of sodas he sold. Okay. So we have that X plus Y. I'm going to switch colors in a second, but we have that X plus Y is equal to 25, and we also have that 2.25x plus 1.50y is equal to 45. I see good ways of doing this one by substitution, elimination. This is a great example, though, of a place where we could do test-taking strategy to get a single point. Remember that a numerical answer will receive a point. And this second part is out of 2 points. So if you graph these two, y equals negative x plus 25, and y equals parentheses 45 minus 2.25x close parentheses over 1.5, graph those two, find their intersection points, state the intersection point, you get a point out of 2. Big deal. So you don't have to actually know how to do this to get 1 point, but you do have to know how to do it to get 2. And also, since the answers are going to be integers, you could actually just scroll up and down the table of values to get the correct answer. So I'm going to subtract x here. I'm going to subtract x, and I get that y is equal to 25 minus x. And I'm going to substitute that into this equation. And I got 2.25x plus 1.50. Now y is 25 minus x. And that's equal to 45. I'm going to do a nice distributive property. So I got 2.25x plus 25 times 1.5 is 37.5 minus 1.5x is equal to 45. Combine the x's. I got 2.25 minus 1.5 is 0.75, but if you didn't know that, you could use your calculator. 0.75x plus 37.5 is equal to 45. Subtract 37.5. And we get, I'm going to go to this column over here, 0.75x is equal to, go to your calculator, 45 minus 38 is 7, and minus another 5. And then 45, divide by 0.75, divide by 0.75, and I get, by the calculator, I got that x is equal to 10. Okay? Now I wrote a little big, so I'm running out of space here. But you can just write under if you need. Let's see, we got to get the y coordinate. Let's use the first equation, the red equation, to get the y coordinate. So we got that 10 plus y is equal to 25, minus 10 minus 10, and we get that y is equal to 15. Or you could have done y equals 25 minus 10, which is equal to 15. Okay? Good. And good. Okay, so now we're about to drop a mic. We got a 98. We got all the points except 2. Let's actually see what that score is. All the points except 2. And that gives us a 98. Now, this is the first time that I've ever seen this in my life. And I didn't notice this when I was looking at this. 82 is 100. But an 81 is also 100. That's mind-blowing to me. I didn't know that they did that. You could actually lose a point on this test, a single point on this test, and still get 100. Regents creators, I mean, if your scaling said that made sense, fine. I'm telling you, students really appreciate that for sure. I'm sure teachers of struggling students also appreciate that. Or teachers of students who really want to get 100. I think a 99 makes sense there, but you do you, and students really appreciate that. Good job, making an 81 also 100. So if you lose a single point anywhere on this test, and only a single point, you still get 100. That's great news, and that's a great piece of news to almost end on. We're about to drop the mic here. Let's lower this and let's go to the last part of this. A customer has $20 to spend at the concession stand. Determine and state the maximum number of hot dogs he can purchase if he buys 4 sodas. So we have to take into account how much the sodas cost. And we said 1 soda costs $1.50. So 2 sodas cost 2 times $1.50. I don't care what that number is. I care about how to get it. It's $3, but I don't care that it's $3. I care about how to get it. 3 sodas cost 3 times 150 and 4 sodas cost 4 times 150. So the cost of sodas is equal to the 4 sodas times 150. And according to my calculator, that's equal to $6. And the cost of hot dogs is therefore equal to 20. The $20 he had to spend minus the $6 he spent on sodas. I guess him, his wife, 2 kids, or him, his husband, let's say, or 2 kids, or him and 3 kids, or him and 3 of his buddies. Who knows? So 20 minus 6 is 14. And let's say then the number of hot dogs, so the cost of hot dogs, 14, that's also equal to 2.25. I'm going to let, I need to write a let statement here. Let H equal the number of hot dogs. Because the cost of the hot dogs is equal to H times the cost of a hot dog. So H, 2.25 H. Now I'm going to divide by 2.25. Divide by 2.25. And I get that H. So I should actually write that that's greater. He has $14, so that's greater than or equal to 2.25 H. So that's a more correct statement. Get my calculator out. Of course, I could do this on the in my head. In fact, the reason I wrote that equal to a great and to change it into a greater than or equal to was that. So 14 divided by 2.25, and it says that x is equal to 6.2 repeat. H is greater or rather 6.2 repeating is greater than or equal to H. So H equals 6. Circle that. Pick up the mic. Drop the mic. We are absolutely done. I want to congratulate you on getting 100 on this Regents. Or if you lost a point somewhere, I want to congratulate you for getting 100 on this Regents. I'll thank you, and I'll see you in the next video.